If you are an Android developer, you probably already know that what Gradle is. If you are not, don't worry, we are going to explore what Gradle is. Let's get started. Gradle is another build tool similar to Maven and Ant, but Gradle has taken the advantages of both Ant and Maven, and also it has removed the disadvantages of both Ant and Maven and created a first class build tool. So that is Gradle. So if you are using Android applications, if you have developed Android applications, you probably know what is Gradle and how Gradle works. If you are not using Android applications, still many people use Gradle, but not everyone has moved to Gradle because there are lots of applications which are still using Maven because they are self-sufficient and they know what they are doing with Maven. However, understand what is Maven, what is Gradle, and how is it different from Maven. So in this particular video, what I'll do is I'll create a small Gradle project like how I did for a Maven project. We will create a Gradle project and see how the Gradle file looks like and what are the different stuffs Gradle has additionally apart from what Maven and Ant provides. That's what we are going to see in this particular video. So first up, the documentation. So the documentation is pretty good in Gradle. It is something similar to Maven, but it is not exactly like Maven. The first thing which you will notice from Gradle versus Maven is Gradle is based on Groovy scripts. So whatever you write inside Gradle is all Groovy code. Okay, it is not like an XML. So in Maven we write XML. So XML is not like a language, right? You define a configuration file. But Gradle, whatever you write inside a build.gradle file is like a language. So it's like a what do you call a scripting language. You can write scripts which can do something similar to what we do in Ant, right? So inside your Ant file you would have done lots of steps. You would have created tasks, you would have done you would have added some echo statements, you would have added println and stuff like that, right? But in Maven we can't do that, isn't it? You have to define some predefined XML tags and the Maven daemon will automatically run based on the XML tags which you have defined. But in Gradle you don't have to do that. You will have to write your own task if you need an additional stuff, and there are lots of additional tasks which are provided by Gradle like how Maven provides. But the additional thing which Gradle provides is you can plug and play lots of plugins which you can write on your own. So literally on your own, in the sense you can write your plugin with Java code. So basically you can write Groovy code or Java code and use that as a plugin. So I'll give you a typical example where Gradle will be very helpful. Let's say you want to deploy something into your machine, right, into your Linux machine, or you want to push something into your remote machine. Also, after the deployment is completed, you want to do some specific tasks, right? So what you can do is you can create a plugin which will do a deployment, and you want to do some additional tasks, but you have to control that from your code base. So you can give control of that particular post build execution or something which you can create as a task, and then you can give control to the task in your code base. So you can have multiple projects. So based on your project, you can decide what kind of task you want to do. So for example, if you have a Tomcat project, you want to stop the Tomcat, deploy and start the Tomcat, you can control that in your code base. And if it is a different project, let's say if it's a mule project, you have to stop your mule server, deploy and then start your mule server. If it is a VAS, you have to do the similar stuff. Same way for Spring Boot application. So you can do that in a single same plugin, but you can give control to the code base itself. So you can give complete control to the code base, and you can override what you can do apart from what is there in the plugin, right? So basically you can extend stuff and then write. Okay, so the other good thing about Gradle is it uses Groovy DSL. So if you know about domain specific language, Groovy DSL provides some predefined set of commands, or basically user friendly way of notation. Like for example, if you have a dependency, you just say dependency and then you just say open brace close brace, you are done. So you don't have to say dependency open a tag and then you use the group ID and all those things. So I'll show you that in a minute, right? So that is another good thing about Gradle. So you can write lots of code inside Gradle, and also if you want to create custom tasks, you can do that inside your Gradle. You can easily create your custom task. You don't have to create a plugin as such. You can create your task internally. I'll show you that as well, right? So let me go and quickly create a Gradle project. And if you notice, Gradle has very good support from IntelliJ because Android Studio is developed by IntelliJ, basically JetBrains, and Android applications are basically based out of build.gradle, basically the Gradle deployment tool, the build tool. And same way IntelliJ provides first class support for Gradle project. So I'm going to create a new project. So here I'm going to select a Gradle. So I'm not going to select Maven. So if I have to create a Maven project, I will select Maven. I need a Gradle project. I select Gradle. I just wanted a Java project. I don't want Groovy or Kotlin. So I'm going to select only Java. I just say next. Same way you have to give a group ID. So I'm going to say com trek primers. And here I'm going to say Gradle example. Right? So next is I'm just going to use the custom, the default Gradle which is going to be installed. So I'm going to say next. If you have a custom Gradle home, you can give that there, but I don't want anything custom, right? I'm going to use the default Gradle version which IntelliJ is going to provide me, right? So the Gradle project is created, and if you notice here, the Gradle build is getting triggered, right? And similar to how you had the Maven project created, so for comparison, I have opened the Maven project as well. Let me close everything for a second, and let's look at the structure, right? The structure of a Maven project was like this, right? You had a target folder where all the class files got generated. So in Maven, there will be a different folder called build, okay, where all the files will be generated. There are 2 or 4 files here, right? There is something called build.gradle, settings.gradle, okay, gradlew.bat or gradlew, which you can decide based on your platform. So if you have a Linux based platform, you can use gradlew to run your build. If you have a Windows based platform, you can use gradlew.bat. So build.gradle is similar to pom.xml. So in Maven we had only one file, which is the pom.xml, right? In Gradle we have build.gradle, and there is a settings.gradle where you can keep some general settings which you want to use across your projects. So if you have multi-module projects, you will have multiple build.gradles, and you can inherit stuff from the settings.gradle. I'll cover the in-depth coverage of how the multi-module projects work in a different video, but yeah, first let's see what is build.gradle, right? The moment build.gradle is seen, IntelliJ automatically identifies it's a Gradle project, and it shows up this icon, right? It also says, do you want to configure something? Okay, I just say apply suggestion. This is just going to link my DSL with this particular file. So the first line in the file is the group, so which is basically the comtech primers. This is the package which I need to ship my project to, right? The next one is the version number. So this is exactly similar to what we had here. You had a group ID, artifact ID, packaging, version, stuff like that, right? But if you notice here, it has a much simpler notation, right? This is the DSL. So if you say group, this will have a notation. So this will be internally, if you see here, I just did a control B, and this is directly going to a Java class, which is project.java, which is inside Gradle, right? If you do a group, it is internally doing a set group. So if I go inside it, if you notice here, there's nothing but a method. And Groovy, if you know about Groovy, it uses reflection, and it runs on the JVM. It's another JVM language. So that is why if you see, the project is still named as Java, right? But still you can access it from a Groovy file. So the intercompatibility or the interoperability is good between Groovy and Java and Groovy, right? It is basically literally like a Java file, right? So whatever you do with Java, you can do in this file. I'll just show you in a minute. The next one is the plugin which we are integrating. So here I am saying that apply the plugin Java. So if you want to have a Groovy plugin, you can just say Groovy. If you have a C++ project, you can just say C++, CPP. So similar to that, you can add plugins directly. So if you have Maven, what we do is in the Maven project, you would have added a plugins, and then you would have added a plugin, right? So instead you just say here apply plugin, and then just mention the name of the plugin. That's it. So Gradle does the import of the plugin, and this plugin could be a Java code base which you had written as a plugin. So you can write the code base in Java, the plugin as a Java project, and then you can just apply that plugin here. We will see that later in some other video. If you want me to make a video on how to do plugin development in Gradle, do let me know. I'll just do that. Next one is the source compatibility. What is the Java version which we are going to use. The next one is the repository. So this is nothing but the Maven repository which we will be using in this particular project to download our artifacts, right? So if you notice here, this is nothing but a function, right? Maven central, it's a function. If I see what is inside that function, this goes to a function class called repository handler.java. So this is also coming directly from the Gradle API. See, this is the DSL which I was mentioning. So these are nothing but DSLs. So DSLs are nothing but domain specific language. So if you say Maven central, somebody has implemented it. So Gradle has already implemented it. So it directly goes there. So that is what is happening here. Same way for repositories. So repositories also is a, if you see here, it's a closure. So it directly goes to this project. So whatever we have defined outside, it's all inside project, and whatever you have defined inside, it's all inside the respective handlers. The next one is the dependency. So this is similar to the dependency management which we have inside Maven. So you need to do a dependencies, then you say dependency, then you say group ID, then you say artifact ID and stuff like that, right? So you don't have to do that. You can directly do something like this. So if you say test compile, this particular dependency will be imported only for the scope which is test. So if you see here we had something called scope. Here you directly have a test compile. If you don't want it for a test, you want it to have it at the compile stage, you can do this. Let me do this, right? So you can do this, right? Also, if you hate these group ID, the artifact ID and the version number, you can still do this. You don't have to mention that. If you know what is what, you can get rid of these stuff. So you can do even this. So Gradle knows that, okay, the first part is the group, the second part is the artifact ID, and the last part is the version number. You can still do this, right? Much simpler, right? So how much line of code is this? Like, I think 15 lines of code. Here, how much line is it? It's like almost 40, right? So that is the difference between Maven and Gradle majorly. So it's very easy for you to read. So if I need to read this particular file, I can easily understand what it is because of the Groovy DSL which Gradle uses. Maven is something different. Maven is a build tool. It just it is like making your Maven understand. So whatever you write here, Maven should have had it already, and you have to write it only in XML format, and you cannot do any processing here. However, here in Maven in Gradle, right, I can create a custom task. So let's say I create a task, right? I am going to create a task called let's say tech primers, right? I'm going to create a task called tech primers just for our usage, right? And I'm going to say just print me hello YouTube, right? This is just a task, right? I've just created a task, and if I see in IntelliJ there is something called Gradle projects, like similar to Maven projects. Maven projects will be empty right now because there is no pom.xml. So once there is a Gradle project, you can see the different tasks. So these are different tasks which are by default present, right? And I have created a new task, right? So let me open everything and show you that this tech primers task is not there first. And I'm going to do an import, right? And if you see here, my tech primers task has immediately come under the other, right? So if you have a custom task, it comes under other. So this compile Java, test Java, process resources, test resources, these are coming from the plugin, right? So that is why these are under other. If you write your own custom plugin, all these will be coming under this other. If you have a custom task, it all will be coming under other, right? So when you want to build a Gradle project, you can run the Gradle build. Okay, if I just double click on it, it runs the Gradle build here. And if you notice here, IntelliJ has a very good support. It has very good way of showing up the Gradle build, right? But first time we want to learn what is Gradle, right? Let's not do this. I'll show you by running the Gradle, right? So there is this Gradle W. Since this Mac OS is based on Linux machine, I'm going to run the Gradle W. If you are using your Windows machine, you can use the Gradle W.pat. Okay, I'm going to run this. I'm going to give it some task. So for simplicity, I'm going to give the build task, right? And see, let's see what happens. So when I gave the build task, if you notice here, my task ran already, right? My task ran and it gave me the output as hello YouTube, because I had given a println here called hello YouTube. So it automatically ran that. It did a compile Java, it did a process resource, it did process classes, jar, assemble, compile test Java. These are different tasks which the build is dependent on. So basically these are different tasks which needs to be run before this build task. That is why all these ran. So if I want to run only the task called tech primers, it will run only that, right? So if you notice here, I ran the task called Gradle W tech primers. It ran only the task which I had. If you see here, it showed only this task, right? So this is the major thing about Gradle. You can write lots of things. You can write lots of Java code. You can write for loops here. You can do whatever you want here, right? So that is the difference between Gradle and Maven. So in Maven you cannot do that right now, right? It's a XML. Inside the pom.xml, what can you do? You can't write any language, right? You can, but in terms of Gradle, you can use that. So if you want to do any automation, you want to do validation, you can do automatically inside build.gradle. So for example, after your build is completed, you want to write some test, right? As a part of the test task, you can override that here. So let's say there is a, if you notice here, test is already a task. If I click on this, it is already a task which is there, right? So I'm going to write some custom message, test message. So this is going to get printed as well. So as a part of the test task, this will automatically run. So you can override tasks. So you can override your custom tasks. So you can do that as well, right? So if you notice here, test message also came, right? Because it's by default there as a task. If I create as a task, it might not run because it is created as a task. Okay, test is already a default implementation. So why is it throwing an error? Code.test as a task with the name already. Yeah, so if you see here, right, I created a custom I created a new task called task. Gradle is not allowing me, saying that okay, there is already a task which is existing, because you cannot override that task. You can extend that task using the same test, but you cannot override saying okay, I am defining a new task, because when you say task, you're defining a new task and registering it with the Gradle daemon, right? So that is about Gradle. I hope you guys understood. So what else I can show? I can show you by so after I built, right, if you see here, there is this folder called build. So similar to target inside Maven, you have build, and there is something called libs where you will have the jar, the final jar. Temps will have the other basic stuff, right? Nothing else. Then you have the Gradle wrapper. So Gradle, using the Gradle wrapper, you can use the Gradle version or the Gradle distribution. So if you see here, this is using the Gradle version 3.5 RC2, right? Using this Gradle distribution, you can give your custom Gradle distribution. Okay, if you have your custom definitions, you can have that here. So definitions are nothing but something similar to here, what you may have written here, right? You can have your own custom Gradle definitions and use that. So you, for example, like tech primers, I can write some task called tech primers, put it in my Gradle distribution and use that in this particular project, and the tech primers will automatically run. So you can use it for deployment and stuff like that. Like if you want to deploy or you want to automate something for all your projects, you can create a common distribution and use that distribution in all your projects, so which is very useful. So you can define your DSL as well, so you can create your custom DSLs, right? So I think that is what I wanted to cover in this particular video. Hope you understood what is Gradle and how is it different from Maven. So we saw Maven is XML based language, so it's not a language as such. You define an XML, Maven is going to read it. If you want to have something working, you have to use the corresponding plugin and make it work. But in terms of Gradle, you can write whatever you want. You can write your custom plugin, you can plug it in, you can write it in your language, you can write it in Java or Groovy. You can write it in your language and then you can plug it in, right? So that is the difference between Gradle. So Gradle has taken the good features of Ant and the Maven, and that is why Gradle is powerful. And Gradle is being used in all the Android project. If you are going to an Android project, you will definitely have to learn Gradle, or at least understand Gradle. It's not difficult to learn Gradle, it's just easy to learn Gradle because syntax are all like very easy. The good part about Gradle is I found the documentation very good. The documentation is very nice. The API which the Gradle provides is very good. The user manual, which if you go there to the Gradle website, it's very good. They have covered all the DSLs which you can use. Like DSL, I mean, is these are the DSLs. So you say apply, it's a DSL. If I go inside, it's a Java class, right? It's an implementation. So So that is it about Gradle. Let me know what you want me to cover in Gradle in the next video. I can do that. Hope you guys like the video. If you like it, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. If you find this video interesting, share it to others as well who wants to know about stuff, not only the video about Gradle, but for any video in this particular channel. Hope you liked it. See you again in the next video. Thank you.